Hello everyone. Today I want to share my idea about the LeetCode question in the LeetCode 30 days challenge. Uh, this this question is a LeetCode's original question. It's called Members of Islands. Today is April 17th. Okay. Let's start to my idea. Here. Okay. For this question is called members of island. That means the input is an string matrix, two-dimensional matrix. Every element in this matrix is a character or string. Yet they want us to identify how many islands in this matrix or in this land. Okay, so in this input matrix, one is represented. The one represented the island, and the zero represents the sea or water. So for this series of questions, I think my first idea is about the depth first search, or another is the breadth first search. Because we need to identify the such as for this element, we need to identify the up, down, left, right, the three direction of this element is one or not. If this one, it means the adjacency element is the island, is land. Okay, and if that is a zero, it means that land that is not land, is water. So for the depth first search, we need a stack, and I have some notes about the DFS. Okay, the general steps or the logic for the DFS is like that. So let's initial a stack and push the first values you want to identify. And if the stack is not empty, we continue to search the adjacency the element in your input element. Okay, so this is the logic for the DFS. So for this question, we can do this like that. First of all, we need to validate the input, such as if not great or not great. Zero, it means if not great, it means in this direction it's not empty. All right, and this one is means we want to validate in this direction is not empty. So either of these, if either this one is empty, we need to return the zero. It means the input is empty, right? And after that, we need a loop. Okay. First of all, in my experience, I want to do that. Sorry for the tiny input. We need to grade and so for doing that, we need to iterate each element in this input matrix or grid. Right. So because So each element in this input matrix grid is it's a string, right? So we need to find the first element that is len, right? So if the grid 1 and j is equal to a1, it means we find a len, and we need to use the DFS to search the adjacency len, or yeah, that's it. And so we need to DFS, and for this DFS we need this input argument. First of all, we need to input the I and the j. That's the dimension of this point, of this element, all right? And after that, we need to pass the grade, original grade, and for some, for my my experience, I want to pass the dimensional or the size of this grade, and we also need a result, because we need to calculate the member of the islands, right? So if we find the land, no matter how large of this land is an island, right? So no matter how large for this these islands, we need to increment our result, right? And after that, we have to return our result. So let's start to build our DFS. So for the DFS, we need to first add self first, and we need two parameter to represent the dimension of this element in this grid, and the size of this grid. All right, because we need to figure out the up element, down element, and the right element and the left element. So we need a dimensional delta x or delta y. How to represent it? Delta x is like 1, minus 1, 0, and 0, and the delta y is 0, 0, 1, and minus 1. So that means for the first element in the delta xy means x going to 1 and y keep to 0. It means we visit this element, right? And after that, the x is minus 1 and y is kept 0. So it means we visit this element, and so on, right? And that we need a stack. So first of all, we need to we need to push or append the first element we visited into the stack. So stack append. We need a tuple to represent this island dimensions, and after doing that, we need to modify the original grade. That means we no longer visit this point again. So that's x and y is equal to x, right? And well, stack and the first So we need to pop the dimension x and the dimensions y from the stack, right? And we need to visit the 4 dimensions depend on this current element, right? In range 4, right? And the new x is equal to x plus e to dim x plus delta xi, and the new y is equal to dim y plus dy and I. So it means we iterately visit these two elements, these two value, these two value, these two value, and these two value. All right. So, but here, where we need attention for the out of bound, for the input grid, right? So we need to do that, like if nx smaller than 0 or nx larger than m minus 1, or ny is smaller than 0 or ny is larger than minus 1. That means the new visit point is out of the bounds of out of the boundary of the input matrix, right? So we just continue, right? So after that, we need to check whether or not the current visit point is 1 or not. All right. So if the grade nx and ny is equal to 1, right? And we need to append the current index into the stack, right? Because we do the DFS, the deep first search, right? And stack append, still use the tuple and y. And after that, we need to, because we have visited this new nx and ny, right? So right here we need to modify the value of the nx and ny, because we don't want to visit it again, right? Okay. All right. Let me check. Okay. All right. That's it.